Hi all, welcome to my YouTube channel. This channel is going to be about trying to learn new things publicly, beginning with Rust. To start my YouTube channel, I knew it was going to be about learning skills, but I was unsure of how to proceed in doing this. To gather inspiration, I began looking at how other people do this. I found an amazing creator, Nicole van der Hoven, who publishes content about Obsidian, a note-taking app, online. Furthermore, she demonstrates a concept called learning in public with a website. This website is built using a tool called Obsidian Publish. Here you can build a set of notes that you can try to explain concepts and others, and me, to understand. This is currently what is on screen now, and a link will be available below. Furthermore, it allows people to deeply question what you think and what you know. A personal issue I have with writing scripts is that it requires a lot of writing, which is a weak point of mine. I should fix this even without this channel. This issue is not unique, so I searched people who had strategies to tackle this. When I tried to search how YouTube creators did this, I often found a process and a clean edited final product, but I didn't see any of the messy in between steps. I decided that as I want to improve my writing, I would display the processes and the mistakes I made with my writing alongside the material I'm learning in Rust. To start learning Rust, I decided to follow common strategies people use to do so. This led me to a website and the Rust book. The book is a starting place, but there seems to be quite a few avenues where you can branch off from there. I think I'm going to look at web development, as I have previously made a website with Django, and I have a new idea for a website. One thing to consider is that I don't understand Rust, so I will wait until I know more before fully committing to that decision. While proceeding through this book, I am going to try to make connections between Rust and other languages I know small parts of. I've heard making connections between different languages can be useful in learning. The simplest method you can use to compile a Rust file is to use rustc on a Rust file. Doing so creates an executable you can run. You can see this in other languages such as Java that have javac to compile a file. This is not used too often as there's inbuilt support of creating Rust programs through a tool called Cargo. We will discuss this tool Cargo. To start, we will create a hello world file in Rust using rustc. Note that Rust files have the ending rs. To start, we will focus on what needs to be in a Rust file for it to compile. The Rust compiler looks for a main function, which is also seen in Java. Then the behavior of the function is captured between the parentheses. We can then output the phrase we want using a macro println with an exclamation point at the end. This initially seemed like a function with an exclamation point attached. To understand this more, I decided to use the Rust documentation and saw there were quite a few uses for it. There seemed to be a lot of building blocks to make macros, so I decided to focus on proceeding through the book first. To print hello world, we use the macro println exclamation point, making sure to end a sentence with a semicolon. To compile the code, we just type rustc followed by the name of the code we are trying to use. Then to execute, we just type in main, and that's it. TOML is an abbreviation for Tom's Obvious Markdown Language. To talk about the libraries you want to use, you have the name of the library enclosed within square parentheses. You can talk about subfolders of that library by having the name of the library, put a full stop, and then the name of the subfolder. This convention is used in other places such as Python. The conditions are automatically enforced by Cargo when the program is built. Also, you have the advantage of selecting which version of the library you want. This is important if there is an update in the library you are using and it causes your program to no longer work. You can then just downgrade your library to the version that worked. To do this, you specify which version of the library you want to use in your TOML file. To build the project, type cargo build into the terminal. One problem that could arise is that building your project each time to check for errors could be extremely time consuming. To combat this, Cargo has a check command. This runs tests on your code to see if the code will compile but does not compile it itself. There's probably a lot more to TOML, but we will get back to Rust now. To see Cargo in action, let's build our first project. We will create a game where the user has to guess a secret number. This will involve taking a player's input and responding based off its relation to the answer. This will help build skills such as identifying data types, making decisions based off how things could occur. We will also learn how to deal with errors in our code. We will use Cargo, highlighting how TOML is used. I am also going to try build diagrams of the algorithm as seen on the screen. Using Cargo to build our projects, we will create a TOML file automatically. This will hold the necessary dependencies our program needs. We can play with testing different versions of the libraries with our code. We can move back a few versions as shown, or even forwards like so. If we go too far, it will cause an error. It also tells us we can test a beta version of a library, which I thought was interesting. Let's start by beginning with best practices. I have seen people use diagrams to explain their problems, so I will do the same. Here is the diagram of our game. We will create a secret number. The player guesses the secret number. If the answer is incorrect, the player is then informed if it is too high or too low. Then they guess again. This repeats until they win and the game closes out after congratulating them. Let's build this. We start by creating a secret number. We need a library to do this. The library that works for this is rand. We import a library by using the use keyword followed by the library name. The libraries can have some conditions on them, but we have not yet got to discussing that in this project. Note that we need to mention any library we use in our TOML file. Let's state the version of our library as shown on screen. We can change the version of the library used by changing the version in our TOML file. Note if we try to ask for a version that does not exist, we will get an error message. Now we will generate the random number. We use the let keyword to assign variables. An interesting thing about Rust is that it assumes variables are unchangeable to begin. Rust also follows the convention of snake case for variables. The format of snake case is to make the initials lowercase and have an underscore between words. We can see the secret number is in this format. To generate the random number, we use the command rand thread range dot genrange 1 dot equals 100. The 1 dot equals 100 reminds me of the spread operator in JavaScript. We can now take guesses from a player. We don't know how many guesses it will take, so our form of control flow will be one that has to keep working indefinitely. Rust does have a while statement, but this is not used here. I'm a bit confused by this, as having infinite loops can be dangerous, but this may be just an inexperience issue, as I am not sure what the Rust strategy for handling loops is. I looked at the documentation and they can label their loops in order to break loops in certain ways, I think. My doubts originate from infinite loops. If I remove the break condition, does this still compile? It does. I'm unsure if this is an issue, as there are situations where you would like processes to be able to respond indefinitely. We now want to accept guess from the player. To make sure we can change our guess if we repeat, we use the mute keyword after let. If anything goes wrong with retrieving an input, we handle this error with the expect method, and that prints the string if an error occurs. Note that Rust puts a point on the mute keyword to let the function know that the data is mutable. If the data is immutable, the mute keyword is not there and the ampersand is on the variable itself. This is to pass references in safely. This will be explained more in depth later. Now we need to extract the number the player gave. First we need to ensure that we received a number. If we don't have a number, we let the player guess again. We apply trim to remove spaces, then we apply parse to see if it is a number. We use pattern matching to solve any errors that occur. For a number, we keep going with our algorithm. If it is not a number, we continue to the next iteration of a loop. I wondered how the code associated num with the input. Is it a placement pattern? To test this, I changed num to a different word and checked to see if the code still worked. As this worked, I think it is a placement situation. I'll have to investigate this more. Lastly, we need to compare guesses with the secret answer. We do this with the compare library. We get a .cmp function and a pointer to the variable we want to check. Note that as we do not want to mutate the variable, there is no mute keyword. We pass a reference to our variable by using an ampersand. We have three options to run through: larger, smaller, or equal. We tell the player whether their guess is too small or too low and let them try again. If they are correct, we congratulate them and break out of the loop. There are aspects of this code I still do not understand. I think I view the two semicolons as getting a subfolder of a library, but I know that this is false. The reason why is that when importing standard semicolon IO, we still have access to standard. Some part of my model is incorrect and I need to fix it. Googling it, I found a Stack Overflow article that says they are path separators. Looking at the documentation, I was unsure as they showed many cases and I assume there's some overarching principle here. I see in the Rust book that they talk about this in chapter 7, so I'm going to post till then. One thing I did see in the documentation was about absolute and relative paths. I've seen that before in Django. I don't know if it is related to this, but I heard the terminology of RAII, real acquisition is initialization, is in Rust, and that it comes from C++. My next issue is pattern matching in Rust. We can name variables in pattern matching via their placement. This still feels very unclear to me. What happens if we have two or more variables? Do we OK and then have a list of names? Do we use keyword assignment? While Googling it, I found people talking about multiple pattern matching in Stack Overflow, and they referenced the book. Pattern matching with multiple cases appears in chapter 18. They did not mention pattern matching with multiple inputs, which makes me think that maybe this just does not happen. I can experiment for now. Thanks for joining me on this journey. If you want to hear more, join the Discord below or check out the website where I put all the scripts and tasks.